A warm welcome to all viewers. Today we will learn about correction to basic runway length. This is continuation of the previous session. I am Ashok Kumar, Assistant Professor, Department of Civil Engineering, Walchand, Institute of Technology, Solapur. At the end of the session, students will be able to calculate the runway length by applying the corrections. In the previous session already we learned how to apply the correction of elevation. Now we will proceed for applying the correction of temperature and applying the correction of gradient. As per the International Civil Aviation recommendation, the basic runway length to be increased for elevation correction, that is 7% for every 300 meter rise in the elevation. We have taken the example, so 100 meter elevation is given to you and runway length is 600 meter given to you, basic runway length. So we have increased that the 600 meter runway length, applying the correction of 7% for every 300 meter rise. So with that we have got 14 meter is the additional distance to this 600 meter. Now proceed to the temperature correction. As per the ICO recommendation, whatever the basic runway length corrected after the elevation has to be corrected further at a rate of 1% for every 1 degree rise in the airport reference temperature above the standard atmospheric temperature at that elevation. So these are the steps for applying the correction, temperature correction. The first we need to calculate the ART, that is airport reference temperature, and further we need to calculate ST, that is standard temperature at the given elevation, and take out the difference of ART minus ST, that will give the what is the increase in the ART. So for this increased ART we need to apply this correction, that is 1% for 1 degree rise in the ART. Let us take an example to understand how to calculate the airport reference temperature. So there is a 1 month data is given to you out of the 12 months. So 1 month observed very hottest month, and the data for given for that hottest month over here. So from 1 to 30 they have given the temperature, maximum temperature of all the days and average temperature of all the days they have given. So from 1 to 30, average as well as maximum they have given to you. Now we need to calculate the Tm and Ta. What is Tm here? Mean of the maximum daily temperature is indicated by Tm. How to do that? So take out the summation of all these parameters. So here you can take the summation of this value as well as this value. So adding together this will come 1311.6 divided by the total number of the days, that comes Tm value as 43.72 degrees centigrade. That is mean of the maximum daily temperature. Then take out the mean of the daily temperature also, average daily temperature also. So here it is 7, it should be 25. So by mistake it is written, it is 25.7. So take out the summation and divided by 30. So that comes to 26.32 degrees centigrade. So now we know that how to calculate the ART, that is Ta plus Tm minus Ta by 3. So with this we have got the ART as 32.12 degrees centigrade. We will continue for the temperature correction. Again taking the same example solved in the elevation correction. Elevation is given as 100 meter and basic runway length 600 meter, and now we will take a new value of ART 28 degree. Now already we know that this step is already done. 614 is already applying the correction of elevation is done. Now we will continue this correction for temperature correction. The first one, as per the steps we have learned, we are going to calculate the ST value, that is standard temperature at airport site we need to calculate. So at MSL the standard temperature is taken as 15 degree, and we know that what rate the temperature is going to be decreases. So as we go higher altitude, the rate of fall of temperature, as we increase the height of as we go higher altitude, the rate of decrease is minus 6.5 degrees centigrade per 1000 meter. This is the decrement rate, we know that already. So this is the rate of decrement of temperature as we go higher altitudes. For every 1000 meter there is a drop down or lapse rate of the temperature is minus 6.5 degrees centigrade. So now for 100 meter, what is the we are going to calculate? So given the elevation is 100 meter, so for that we have got the 14.35 degree is the standard temperature at the airport site. Now for the second step, we need to calculate what is the increase in the ART temperature. So we know that already ART is given as 28 degree minus 14.535, that gives 13.65 degree centigrade. Now for this we are going to apply the correction of, that is 1% for every 1 degree rise in the ART temperature. So for 13.65 how much? So you know that this relation already we know that. For 1% correction for every 1 degree rise. For 13.65 degree how much? So cross multiply that and multiply by the basic runway length after correction of your elevation, that is 614, that gives 83.81 meter. That is after the correction of your temperature correction. So now here the same thing we have done here. For 1% 1 degree rise, and for 13.65 how much is that value? So for 614 meter, that comes to 83.81 meter is the temperature correction. So basic runway length now we are going to be increased 614 plus 83.81 meter. That is the correction after the elevation and the temperature. So that comes to 698 meter is the length of the runway after applying the correction of elevation and our temperature. ICAO recommends that to check this, the length, the increase in the length should not be exceed 35% of the basic runway length. So we need to check that. If that exceeds, so we need to further check up the whatever the data collected or the studies you have to done. You are going to redo those studies one more time, the data which you have collected on that airport site. So for this example, we see that whether the whatever the length increased in the previous 698 meter, whether it increases more than 35% or not. If it is less than 35%, you can proceed for applying the correction of gradient corrections. Now we will see that whether the length is more than 35% or less than 35%. So we know that the total increment length is 698 meter. And basic runway length is before applying the correction of elevation and temperature is they have given as 600 meter. So with respect to 600 meter, it comes to 16.33 is the increment of the length from the basic runway length. So it is obviously less than 35%. Hence, whatever the correction is done is okay. Now the last correction is a gradient correction. Why we are going to apply the gradient correction? As you already know that if the gradient is very steep, it may cause a premature lift. It means the flight is coming for a lift off. So if if it is coming in this direction, and you see that this slope is very steeper slope. So because of this steeper slope, the flight may go into the air prematurely or before that aim point also. So it will consume more energy, or sometimes another one where we have a slope of something like this, where this gradient is in upward direction. So here is something like this. This is the flight moment is in this direction. So here you are going to see that as the slope is very steeper, for that it will require more energy and it will require a more longer runway to attain the desired ground speed. So if it is in this case, so you will see that the longer runway length is required to go into the air. So that is the reason for as the gradient depending upon the elevation of this point and elevation of this point, that is what it is called as the effective gradient. So here we need to calculate the effective gradient by subtracting the maximum and minimum. So here it is the value is the elevation is maximum here, and here it is a minimum value. So we know the distance of this the total the length over here, and take out the difference of maximum and minimum and divide it by the total length of the runway. That gives the effective longitudinal gradient. So for this effective longitudinal gradient, we apply the correction of gradient correction. So here what is the correction rate they have given? So 20% for every 1% effective gradient. So once you calculate the effective gradient over here, So for that you apply the correction of 20% for every 1% effective gradient. Now this already we have know this what is the effective longitudinal gradient. If you summarize the overall the corrections, the elevation correction is 7% for every 300 meter rise in elevation and above the mean sea level, and temperature correction 1% for every 1 degree rise in airport reference temperature. That is, we know this correction. And gradient correction we need to add it. Once this is less than 35%, then you go for applying the gradient correction. And see that the increment in length after applying the elevation and temperature, that should not be exceed 35%. So you need to check that. So and after that you need to apply the gradient correction at a rate of you need to calculate the effective gradient depending upon the data given to you. For that the effective gradient, apply the rate of correction. That is 120% increment for every 1% of the effective gradient. So in next session we will learn how to take the gradient correction also into the consideration and design calculate the runway length, combining the elevation, temperature and gradient correction. These are the references I have used for preparing this presentation. Thank you.